The main benefits of trenchless tunneling technology compared to open-cut trenching are: minimum impact on the environment, minimum damage to the seabed, no deterioration of seawater quality, fewer emissions, minimum impact on existing infrastructure, realization in densely built-up urban areas possible, no disturbance to tourism, no limitation on shipping traffic, longer lifetime of the pipeline, less risk of subsidence, higher seismic safety, better protection against storms, hurricanes, and the corresponding impacts, better protection against general environmental impacts, protection of the pipeline, minimum efforts to reinstate the site following pipe installation, independent of weather conditions and waves during the construction phase. For the installation of sea outfalls and intakes, horizontal directional drilling, direct pipe, segment lining, microtunneling technology may be used, depending on the site and ground conditions, pipe diameter, and length of the pipe string to be installed. However, feasibility, technology, and economic factors are important.
The following animation shows the application of the direct pipe method in laying a 48-inch gas pipeline with an outer diameter of 1,220 millimeters under a river. The 900-meter-long pipeline is pushed in 3 pipe sections of 300 meters. Depending on the given space conditions on the launch site, the pipeline could also be pushed as a complete piece. The pipe thruster is positioned in a shallow launch pit and is anchored horizontally and vertically. A movable launch seal is fixed onto the front wall of the pit for the prevention of inflow of groundwater and soil into the pit. The microtunneling machine is assembled in front of the launch seal. The front of the pipeline is welded onto the rear of the microtunneling machine. The control container from which the operator is steering the machine, as well as the pipe thruster, is placed beside the launch pit. The whole unit is controlled with the latest technology. The navigation of the machine along the desired drilling alignment is guaranteed by a modern navigation system. The feed and slurry lines, as well as the bentonite lubrication lines, are installed inside the pipeline on rolling support structures. The separation plant is located at a position halfway along the stringed pipe section and is connected over flexible hoses with the slurry lines inside the pipeline. The bentonite lubrication pump is placed beside the separation plant. All electric and data cables are supported through the pipeline and along the outside of the pipeline to the control container. In addition to the installed slurry pump in the machine, an additional pump is installed at the end of the pipe section. The pipeline is carried to the pipe thruster with the permitted bending radius over an adequate slope or ramp. The machine is pushed forward together with the welded pipe section from the pipe thruster through the launch seal into the ground. In strokes of 5 meters, the pipeline is laid under the river. The supply lines of the microtunneling machine are also moved during the pipe jacking procedure. After pushing one pipe section, the next pipe section is lifted onto the pipe rollers and welded to the first pipe section. With each coupling procedure, all supply lines which are placed inside each new pipe section are connected with the previously laid out lines to make a connection between machine, steering container, and separation plant. In this case, a simple pit without special ground support system is built. After having reached the target point, the microtunneling machine is recovered and the connection of the pipeline can be completed.